everybody, and welcome to another video of Tutor. So today we're going to be covering sequences and series. So a sequence is simply a list of numbers such as 1, 2, 3, 4, and 5. And a series is formed by just adding them up. So here, the highlighted in pink is a sequence, while this highlighted in green is a series. And so if a sequence or series has a specific number of terms, it's finite. So like if it continues like forever, then it's infinite. So yeah, that's just sort of the definitions. So in an arithmetic sequence, the difference of two consecutive terms is constant, and the difference is often called the difference in a arithmetic sequence is usually called the common difference. And so the nth term in an arithmetic sequence, we can say the arithmetic sequence is a plus d, a plus 2d, all the way up to a plus nd. And how we can find the number of terms in this kind of arithmetic sequence is, well, this has the first term has 0 d's, second term has 1d, the third term has 2 d's, and so if we continue this, we'll find a pattern, and that is, well, you can see there's 1, a 1 becomes a 0, a 2 becomes a 1, a 3 becomes a 2, and so the nth term we find becomes to be the have n minus 1 d's. So in our sequence here, the number of terms in this sort of sequence is n plus 1. And we can kind of use that to find that the nth term in an arithmetic sequence, which I'll denote as a, turns out to be a plus n minus 1 d, where that a is the first term, n is number of terms, and then d is the common difference. And if a term in an arithmetic sequence is exactly in between two other terms, then the term in the middle is the average of the two other terms. So for example, let's say we have an arithmetic sequence 3, 6, 9, 12, a, and 18. And they're saying, what is a? Well, we can simply see that that's 3, that's 3, that's 3. So this will have to be 3, which is 15. So we get that a is 15. But what we can also use is, well, that's our first technique. Our second technique would be that a is simply just the average between these two numbers. So 12 plus 18 over 2 is 30 over 2, which is 15. So we get that a is 15. Therefore, if a term in an arithmetic sequence is between two terms, then the unknown term, then that term is simply the arithmetic mean of the two numbers. So yeah. The next thing is when we add a group of consecutive numbers. So this all right here was arithmetic sequences. So I'll highlight it in red. That's not a highlighter. Yeah. This right there is an arithmetic sequence. So I guess I'll write that in a title if I can write at all. So this is like the overview, like the definitions. So that's not really part of arithmetic sequences. But yeah, other than that, we've got and I guess I'll highlight that. So that's just this first section. The next section is what we call arithmetic series. And there are a few important things. So the first important thing is the sum is the number of terms times the average. The average, I guess I'll just write it like that. So that's the number of terms, and this is average of first, and that's not an and last. And we can sort of write that in a kind of more complex way. So the sum we can also say is n times 2a plus n minus 1d over 2. And that's effectively the same thing as this thing up here. Because this right here is the average, and n is the number of terms. So I guess I'll write that down. This is number. Wait, I already wrote it down. So n is the number, and then a is the first term. And then d is the common difference. You know what? You guys know what d is because I already explained that before. So, okay, I can't undo it. Yeah, so that's the sum of an arithmetic series. And with this formula, we can really write the sum of the first n positive integers. Which we find is n times n plus 1 over 2. Because we have n is the number of terms, n is also the final term, and d is 1, and the first term, which is a, is equal to 1. So if you really can't memorize the previous formula, then just use that. And that's pretty much it for arithmetic things. now here we move into geometric sequences. Okay. Sorry, I'm wasting time here. Okay, so we have in a geometric sequence, instead of a common difference, it's a common ratio. So a geometric sequence with first term a and common ratio r has nth term a to the r minus 1, a to the rn minus 1, where r is common ratio. A is first term. And then n is number, which I already specified. So yeah, the nth term. And if we have, I'll just type it. If a term in a geometric sequence of positive integers, because this won't work if it's not positive, is between two terms, then that term is the geometric mean, which is the square root of the two numbers. So for example, let's say we have 1, 2, 4, 8, a, and then 32. Well, we have this is 2, this is 2, this is 2, this is 2, so a would have to be 16. However, we can solve it with a different technique. We can use the geometric mean. So we were given that a equals square root of 8 times 32, which equals 16. So do whatever you feel is more suitable to you. And finally, we're done with this section. We have geometric and basically the sum. And the reason why I suggest using this instead of any other formula that your teacher gave you is because, let's say there isn't a designated number of terms. Let's say that r is between 0 and 1, where that is included but that 1 is not included. And let's say n has infinity. Let's say you have an infinite number of terms. Well then, your formula simply becomes a times 1 minus r to the n over 1 minus r. But because r is a fraction, you have r to the infinity is basically 0. Because let's say we raise 1/2 to the infinityth power, it becomes so close to 0 that it's basically 0. It's like, yeah, it is 0, essentially. So, don't dispute that in competition, first of all. And second of all, the thing simply becomes r to the n equals 0. So we have a over 1 minus. So, if these conditions are satisfied, we have sum is 8 over 1 minus r. And this part is for infinite series. So that's pretty much it for sequences and series. Hopefully that helped you. And